Assalamu alaikum. Welcome to my channel Physics Made Easy. Today our topic is projectile motion. Projectile motion. First of all, let's try to understand what a projectile is. What a projectile is. When a body is thrown into space or air with some initial velocity and allowed to fall under the effect of gravity alone, such a body is termed as a projectile. I repeat, a projectile is a body thrown into space or air with some initial velocity and allowed to fall under the effect of gravity alone. For example, this becomes a projectile. Two important conditions that we must remember for a body to be a projectile are that one is a body must be thrown with some initial velocity and the body must have no force other than that of gravity on it. For example, this is the surface of Earth. Let this be Earth's surface, and this is the body thrown into air. When you throw a body into air, it falls like this. So when you throw it, it falls like it will take this path. The body that you launch is called as projectile, and the path followed by the body is called as trajectory. So you must remember the terms. One is projectile that we define. The next thing is trajectory. So trajectory is the path followed by the projectile. The position on the surface of Earth, the point on the surface of Earth wherefrom you projected the body is called as point of projection. Just like this point is called as point of projection. You must remember all these terms. Point of projection. So point of projection is the point on the surface of Earth from where the body is launched. The angle that its initial velocity makes with the horizontal, makes with the surface of Earth is called as angle of projection. The body, while going up, attains certain maximum height. The maximum vertical distance attained by the body is called as maximum height. You must remember all these terms. The maximum vertical distance attained by the body above the surface of Earth is called as maximum height, and the maximum horizontal distance covered by the body is called as horizontal range. Is called as horizontal range. While going up, the body takes some time to reach the maximum point, to reach the highest point. The time taken by the body from point of projection to reach the highest point is called as time of ascent, and it takes some time from highest point to reach the Earth. That time that the body takes from the highest point to the surface of Earth is called as time of descent, and the time that the body spends in air is called as time of flight. So we can you just remember these terms as well. One is time of ascent, is the time taken by the body, taken by the projectile from here to here, and next is time of descent, is the time taken by the projectile from highest point to arrive at the Earth, and there comes time of flight. Time of flight is the time that the projectile spends in air, or we can say time of flight is the time taken by the body to cover all of its trajectory. or we can say time of flight, is the sum of the time of ascent and the time of descent. Now, we must take care of some assumptions that we use here. One is, we neglect the air resistance. So one is to neglect the air resistance. Second is to neglect the curvature of Earth. We know that air is not flat like this. It is its surface is curved. But if we take, for example, if this is the surface of Earth is curved, and we take a small part of it, that small part of a large curve may be taken as flat. A small part of a large curve may be taken as flat. So, our next assumption is to neglect the curvature of Earth, to assume that Earth is flat, Earth's surface is flat. The third very assumption is to neglect the rotation of Earth. We know that Earth is not stationary, it is rotating. Earth is rotating about its axis. So here but its rotational speed is small. So here we neglect the rotation of Earth. Now our fourth assumption is to take acceleration due to gravity as constant. We know that acceleration due to gravity is not strictly constant. It depends upon height, it depends upon depth, it depends upon the rotation of Earth, it depends upon the latitude. So, acceleration due to gravity is not strictly constant. But near the surface of Earth, we here take it as constant. So, all these four assumptions we must take care of. I'll repeat all of them. The very first is to neglect the resistance of air. The next is to neglect the Earth's curvature. The third is to neglect the rotation of Earth. And the fourth one is to take acceleration due to gravity as constant. Now, we shall come towards a principle called the principle of physical equivalence of projectile motion. This principle we'll use here. According to this principle, I will repeat, the principle of physical equivalence of motion. According to this principle, the motion of a projectile is a motion in two dimensions. It's a motion in plane. In fact, the name of our chapter is also motion in a plane. So, according to the principle of physical equivalence of projectile motion, the motion of projectile is a motion in two dimensions. So it can be discussed into two parts, the horizontal part and the vertical part. And that both of these motions, the horizontal motion and vertical motion, are independent of each other. This principle has two consequences. The very first is that acceleration due to gravity acts vertically downwards. So it will not affect the horizontal motion. So the force of gravity acts vertically downwards. So there will be an acceleration vertically downwards equal to acceleration due to gravity. Whereas this gravity, which is vertically downwards, it will not affect the horizontal motion. The next consequence is that since there is no acceleration along horizontal, so horizontal motion is uniform motion, whereas the vertical motion is not uniform motion. The vertical motion is uniformly accelerated move. Why uniformly accelerated? Because acceleration due to gravity is constant. We shall now try to find out the equation of trajectory. Or we may be asked to show that the trajectory of a projectile is parabolic. To show that the trajectory of a projectile is parabolic. Here we shall make use of principle of physical equivalence of projectile motion, which allows us to divide projectile motion into two, one horizontal part and vertical part. Let the projectile be launched with initial velocity u, which makes an angle of projection theta with the horizontal. Let us represent the horizontal components by the notation x, while as the vertical components by y. So the initial velocity u will have two components, x component and y component, horizontal component and vertical component. The horizontal component will be ux, while as the vertical component be uy. So the projectile motion can be divided into two. One is horizontal motion. We shall write the parameters for horizontal motion on one side, while as that for vertical motion on the other side. Horizontal motion. The next is vertical motion. So we know there is no force other than gravity on the projectile, and that gravity acts along y-axis, along what's called the vertical. So the acceleration imparted by that we write here ay, that will be equal to acceleration due to gravity, but negative. Why negative? Because acceleration due to gravity acts downwards. And there is no force along horizontal. When there is no force along horizontal, so there will be no acceleration along horizontal. So horizontal acceleration, which we represent by ax, that will be 0. The next thing is that when let this be vector u, initial velocity, and this be theta, and this be x, it is here ux, and it is here uy. So here ux in this triangle, in this triangle, in this triangle, if it is uy, this too is uy. In this triangle, perpendicular by hypotenuse, perpendicular by hypotenuse, perpendicular by hypotenuse will be equal to sine of theta. This will give us uy will be equal to u sine of theta, u sine of theta. Similarly, ux, base by hypotenuse, base by hypotenuse will be equal to cos of theta. You know that, Pandit by Pandit, Hari Hari Bhai. You know all these. So this one is sine, this is tan, this is cos. So implies ux is equal to u cos of theta. Ux is equal to u cos of theta. So the horizontal initial velocity will be u cos of theta, while as the vertical velocity will be u sine of theta. The vertical initial velocity, vertical component of initial velocity will be u sine of theta. What is theta? The angle of projection. Now we shall use the basic kinematic equations. You know all them. One is v is equal to u plus at, let me remind you. The next is s is equal to ut plus 1 half of at, 1 half of at square rather. The third one is v square minus u square is equal to 2as. While v is final velocity is initial velocity is acceleration and s is distance. So, and t is time. Here, we shall use this one for horizontal and vertical. Let's take first horizontal part of this, but we will write x as the horizontal distance instead of s. So s is in general. When we will write horizontal components, we represent them by the notation x. So horizontal, for horizontal motion, we will write x instead of s. So x is equal to u. For u, we will write it is horizontal component ux into t plus 1 half of not a but ax t square, or x is equal to u. We know that it is equal to ux is u cos of theta, so we will write here u cos of theta into t, this t plus 0. Why 0? Because ax is 0, so it will become here 0. Or we can say x is equal to u cos of theta into t. Now, discussing the vertical part of motion, we shall write this time for vertical motion we shall write y instead of s. So y is equal to not u but uy into t plus 1 half of ay into t square, implies we know uy is how much? U sine of theta, u sine of theta into t plus 1 half of how much is ay? Acceleration along y-axis, that's minus g into t square. Now, what we'll do this time, we shall take here, we shall modify this equation just to find time, an expression for time. That time we'll use here. So this will become x divided by u cos of theta is equal to t. So t is equal to x divided by u cos of theta. T is equal to x divided by u cos of theta. Using this and this, we get y is equal to u sine of theta into t. So what will into t, but t is how much? X divided by u cos of theta. X divided by u cos of theta. But this minus will come out. It will become minus 1 over 2g into t square. T is how much? U divided by, x divided by u cos of theta. X divided by u cos of theta. Or we'll write, but it has square here, or it will become y is equal to u and u will go, sine theta divided by cos theta, that will become tan of theta into x minus g is here divided by 2 is here u square cos square of theta into x square now. For constant angle for any particular angle of projection theta, tan of theta is constant and cos of theta is constant. For example, if theta is if angle of projection is 45, then tan of theta is 1, that's constant, and cos of theta is 1 over root 2 or 1.44, I think 0.707. That too is constant. So this thing is constant and this thing is constant. I will write first the term containing x square. So minus g. I will write this term first, this second. Cos square of theta x square. This will make no difference, but it's customary to write the terms containing variables of higher order, higher degree at first. So this thing is constant. G is constant, initial velocity is constant, 2 is constant, and cos of theta for any particular theta is constant. So this thing is constant. I will represent this constant by A and this represent this constant by B. So the equation will become y is equal to minus this minus ax square plus bx, while b is equal to tan of theta and a is equal to this much. Both of these are constants. So what do we get? This is an equation. Which equation? It has degree 2. So it is a quadratic equation. It is a quadratic equation in two variables, x and y. X and y is a quadratic equation in two variables. What does a quadratic equation in two variables represent? Of course, you do know that a quadratic equation represents a parabola, just like a linear equation represents a straight line. A quadratic equation represents a parabola. For example, the general equation of a parabola is ax squared plus bx plus c. Here, the constant term c is 0. It's not involved here. Now, we found the equation of trajectory. And the equation of trajectory is a quadratic equation. A quadratic equation represents a parabola. So, the trajectory of projectile is parabola. That we proved. But how do we know that it is parabola like this? Concave downwards. Because we know that if the coefficient of x square is positive, then parabola will be like this, concave upwards. And if the coefficient of x square is negative, then the parabola will be like this, just like we do have. So, as do we expect, this negative sign indicates that the parabola is concave downwards. This equation, this quadratic equation, tells us that the trajectory is parabola, and this negative sign, negative coefficient of x squared, tells us that the parabola is concave downwards.